Please have a seat.
Test.
So for this second panel, we're gonna talk about the same thing that we did in the first one, working in ZK with our 4 panelists. Yeah, take a seat. But this time we're gonna focus on maybe the technical side of things. So yeah, please join us in the front. Try to be not too noisy, please. Come here, don't be shy. And while people are taking their seats, I'm going to take mine as well. And well, you know what? Let's start by setting up the stage. So maybe Ming, you can start. So just tell us, your name, what you currently do in 1 or 2 minutes, so that people know kind of where you come from.
Yeah, my name is Ming, Ming Guo. I'm actually the organizer of this space. We're doing a ZK VM called ZK MIPS. Very straightforward. Yeah.
Okay, cool.
Okay, yeah, my name is Oleks. I'm lead of cryptography at Distributed Lab, and at the same time, I'm contributing to Rarimo protocol.
Hello everyone, I'm Tracy. I'm the co-founder of Pluto. We work on a technology called web proofs, which is a proof of internet data, and it can be used to build new types of applications.
Awesome. We have only 4 mics, so maybe you just.
This is Alan from Brevis. We are building ZK coprocessors to assure attest the data integrity.
Awesome. So let's dive right into it. So maybe we start with you this time. So what was your first encounter with ZK? So how did you get started really with this industry?
Yeah, I actually come from a background that is very different from ZK. It's kind of far from ZK and cryptography as all. Because originally I was doing a PhD in AI, in artificial intelligence, doing all these kind of deep learning stuff before. It was almost like 5 to 6 years ago. And then after graduation, I started a company that is doing AI for science.
Okay. So from the AI angle.
Using AI to accelerate the scientific discovery. So to be more specific, we use AI to accelerate the drug discovery. So the drug industry is kind of tedious because you're going to be using like more than 10 years and then more than $2 billion to actually get one drug approved. And then their traditional way of developing this drug is just tedious, and it's so costly and so expensive, and so it takes so long a time. So that's why AI could come into play and try to figure out the better way to find better compounds, better drug candidates to go into the clinical trial.
And then you switch to ZK's.
Yeah, so so that's actually one of my stories, because originally I was thinking, the other thing is going on pretty well. At the same time, I was actually also seeing the ZK related things, because the ZKML thing, because at the time there's fake news around everywhere. So people just begin to use some pictures that have been manipulated in the news as a media weapon. So I was quite impressed by that kind of manipulation thing. And then that is exactly where I bumped into this ZKML thing. So basically combine these ZK protocols with ML AI intelligence so as to attest the model integrity. So as I said, we are doing data integrity, but we can also do the model integrity, right? So that's the start of the beginning of, I got to know that ZK is something there, and it can be actually be combined with machine learning. Okay, and then I was also surprised to find out that ZK is becoming more and more popular in the domain of blockchain. So that's where I began to become interested in that thing. Yeah.
That makes sense. Like the way you got sneaked into ZK was from ZKML, which as an AI guy makes sense.
Yeah, exactly.
So how about you, Tracy? Please tell us maybe your background and then how you got into looking into web proofs.
Yeah, sure. So I've been a software engineer for a while. I worked in a bunch of big Web 2 consumer companies and started getting interested in crypto 4 or 5 years ago. I think I learned about ZK first with Zcash, which is like the private blockchain canonical use case of it. But I had never really thought about it for anything but private blockchains before. And I remember seeing state proofs actually. And that was the first big use case beyond just private state transactions, where I was like, oh, this is actually pretty powerful for application developers. So state proof lets you prove something about a historic blockchain state. and that got me excited. And then I saw there was just a litany of use cases around that. So there's like proving an email, proving a piece of internet data, proving about your passport, and these made me excited for what could be built by new application developers.
Okay, makes sense as well. How about you, Alex? Which kind of use case lured you into the space?
Yeah, my journey started probably more than 10 years ago. I started working on cryptography, including threshold cryptography, etc. And then I came to blockchain probably in 2017. And it was started with Monero protocol. And when I investigated how it works, so my world was changed. And there is one another protocol which is very underestimated, the Mimblewimble protocol. It's so fucking cool. So it includes really like simple primitives, but the final result is, that's really magic. And when you understand that the privacy and the cryptography is so elegant, you cannot build another stuff.
Okay, interesting. More like the cryptography angle, I guess, for you, for your first step into ZK.
Yeah. So I started like a cybersecurity engineer, and only then, switched to blockchain and zero-knowledge proofs.
Okay, that way that makes sense. How about you, Ming? So what was your first encounter with ZK?
Yeah, so I consider myself a serial entrepreneur. So my background is software engineering, and I worked as an engineer in Silicon Valley for like 1 or 2 decades. And I started my crypto career, I think, at the end of 2017, or earlier that I joined like various Bitcoin study groups in eBay. And
Nice one. I didn't expect that.
Yeah, they have study groups back in like 2013, 14. Anyway, so this is definitely some technology I was looking back then to think one day they might change the world. But it was around the end of 2017 that I think many people entered around that time. So I started with some of my buddies' first project. It was like kind of like we call like extending Bitcoin through like a DAG, direct acyclic graphs kind of technology, and we want to combine all the fancy technology at that time. For example, DAG and privacy preserving technologies such as like employed by like a Monero, and if you remember, and there's something called Mimblewimble, if you guys remember too, later green, and also smart contracts. Of course, it's kind of too much at the time. We did reach to the stage. We raised a lot of. We actually raised a lot of funding, but everything kind of just stopped at the beginning of the pandemic. So the testnet is still, we reached that stage, but it was not sensible to do a a crypto launch. Yeah. So I started another project with friends as well. So that's the meta story. And fast forward to, that was kind of success. And fast forward to ZKM is because Metis adopts a optimistic role approach, right? Okay. So it's actually MIPS based, right? And we all know that optimistic rollup needs 7 days to settle, to finalize the transaction. Yes. And that was always considered like a shortcoming, but it's actually, in some cases, that's actually the best way, because some people would rather wait longer to get their most valuable transaction, the kind of security that no other can assure them, right? Some people just don't trust mass, right? So the idea was to just add a component of ZK. So that was born between the collaboration between OP and us, and short is that that collaboration kind of just collapsed, and we decided to go our own way, and that was born ZK MIPS, and then of course the aberration ZKM. So that's my our origin story.
Okay, interesting.
Yeah.
It's quite different for you. It's more like a kind of almost a technical reason that you need to have.
Oh, the
to
technical
implement
reason
that.
I mentioned MIPS is a very natural choice is because like OP is MIPS, and also I see MIPS as the simple and elegant RSA. It's I always joke that MIPS is the original RISC Zero, right? So yeah, and nowadays you see many variety of ISA chosen for doing ZK VM.
Yeah.
For example, like Lita, they designed a new ISA that's very optimized for ZK. We're not at the early time when like StartNet started all this.
Yeah.
They have Cairo, which is very simple, 7 instructions. Now it's much sophisticated, but the reason to still do ZKVM based on a real CPU is because there are a lot of legacy applications and devices out there that you actually probably want to do some security application verification and put them on chain. For example, if you're using ZK MIPS, you can probably take a 2-decade-old binary and generate a proof and just verify it on chain. We can do that today. And that cannot be said for like RISC-V devices because RISC-V is so fragmented. Your proof probably doesn't match any vendor on the market. So you have to redo it using your own compiler and everything.
It
so
makes sense. You're enthusiastic about MIPS. I mean, it makes sense for you. But maybe we can take a few steps back and come back to while you were digging into ZK. Actually, how much did you need to know about it? So maybe we'll switch to Oleks, coming from the cryptography angle. For you, was it just yet another cryptography domain, or did you have like some specific ways to learn about ZK and actually implement the thing?
ZK would be useless if it couldn't provide some properties. For me, privacy matters. So, and yeah, I remember the time when we have written Sigma protocol and bulletproofs manually for implementing the custom protocol for payments, because that time we hadn't like any libraries for that. Right now, the regular developer doesn't care.
Yeah.
And why ZK is interesting? Because right now, a lot of people think that's useful right now for execution integrity. So all rollups inherit this conception. Yeah. But at the same time, I believe that the next cycle will be on top of privacy. So I believe that in 5 years, a lot of DeFi applications will require some eligible privacy. When you will be able to send a private payment, but at the same time to prove that you're eligible, you are not included in some sanction list. You receive this money not from some misbehave account, etc. And that's the reason why I love this domain.
Yeah, and actually that's interesting because you're talking more about the use case, which maybe Tracy was also your approach as a software engineer. You were looking into ZK to find how that can be used actually. So what was your journey for you to discover and learn about these notions, make sure you understand it to then be able to use it properly with maybe a new use case like web proof?
I think I was intrigued because when I first encountered ZK, it let you express something with a computer that I didn't know you could do before. The ability to make like a succinct statement of a computation and almost like have a hash function or a digest that you can send to a verifier and they can verify this. That shocked me because I didn't realize I could actually kind of like compress a statement about computation. And I've been working on computers for like 20 years, so there's not a lot of new things I learn about computers. So I was like, this is pretty interesting. There might be something under the hood here. And the more I thought about it, I think having that ability to describe perfectly a computation and succinctly verify it is super powerful, obviously, in blockchains. But I think the privacy properties are also super rare as well. There's almost no privacy technology that abstracts in a way that a normal developer can actually like write a program and then arrives at something that is privacy preserving. And so it's a really powerful programmable primitive for privacy, and something that's missing in the internet.
And when you discovered that, what was your own process actually to learn about this? Like,
Yeah,
how did you learn about it?
I think this made me curious, and I guess as an engineer, I build things. So I was like, I'm gonna implement Plonk, and try to reason about how Plonk works.
Getting your hands dirty.
Yeah,
basically.
so I implemented finite fields and kind of worked my way up to an implementation of Plonk, and then at the end of that, I was like, oh, okay, this just makes sense. It's actually not that confusing. I'm just committing this trace of computation into this thing, and I'm blinding it, and at the end, I'm going to get a verifiable commitment. Yeah, that was my process. It took me 4 months or something to really go from not knowing much at all about it to feeling pretty confident.
Okay. And so what about you, Alan? Maybe was it a similar process? You basically had to get your hands dirty, maybe with ZKML in your case, to understand how that works?
Yeah, thanks for that question. So basically, I started with the basic zero knowledge of the zero knowledge. So because because at the time I was watching this MOOC from the Berkeley, where they have this zero knowledge proofs, where 5 professors are giving lectures, like Dan Benet, Yupeng Zhang, and they have a pretty good materials there to get you an overview of what is happening in the theoretical world. So from the complexity theory to theoretical computer science to interaction complexity, all these kind of things. So I basically spent maybe one or two months to actually watch them over and over again until I feel comfortable that okay, I know something about theory. But things are kind of similar because understanding the theory of the ZK is just the beginning, because at the end of the day, you're going to be implementing it. So ZK is nothing without code, right? So that's where I started to write code by myself. Yeah, so again, so keep watching some new materials. Also, the ZK whiteboard session is also very helpful.
Thank you very much.
I benefit a lot from that. And also, writing code is going to be helpful, especially for my everyday work.
Yeah, again, getting your hands dirty. Yeah, just taking a break to say the next ZK whiteboard session will be actually out in 2 days with our very Tracy as a host. And yeah, I can tell you, since you're here, it's going to be about ZK VMs. So yeah, if you're into ZK VMs, check it out. But maybe we can start talking just a little bit about this, because you're basically building a ZK VM, right, at ZKM in a way, with ZK MIPS. So we talked about how you learn new things and how you basically jump into the rabbit hole. And I wanted to ask you, Ming, because you probably did the same thing, but where do you stop? Because you can always go further down and dig into the math and then go back in history. And as an entrepreneur, where do you say stop and say, okay, I know enough, and now I'm ready to actually build something new and discover this new world?
Right. So we're actually at a very interesting point in history, right? So we're literally at the start of a new cycle, right? If you stay in this space for some time, our industry is cyclic, right? So prior to today, or this week, we're kind of in the build stage. We build infrastructure. You see all these ZK EVM, ZK VM projects, infra projects. But from now on, the competition should be in the application space. You want to bring new users to space. Users are never, interested in the crypto, in blockchain. For example, I heard some friends are joking that my mom is asking me what happened to Bitcoin, right? So when someone's on the street talking about blockchain, this is a new era starts, and every new era needs something new, right? So I think the most exciting aspect of ZK VM is that it's so powerful, right? It can probably redo everything in the space of crypto and blockchain all over again. Like back in 2 weeks ago at San Francisco Builder Week, someone was presenting something called a ZK Binance. And I say, why Binance? Binance is the biggest, exchange. So what would you do differently? He said everything. I could just redo that with a lot less effort for security and everything, because ZK VM can provide that capability. And I know this, but I was still shocked, and I was rethinking this, that it will not only to rebuild everything in a more secure way, it could probably also enable applications we don't even can fathom, right? So something new, something fresh. is going to drive the new users. So the next like billion, 10 billion TVL will come from apps that's not existed before. And I'm very excited that ZKVM can be one of the foundational technology to enable that.
Okay, yeah, that's. I mean, I think we all agree on that on this panel. Maybe to change a bit topics, I wanted to ask you. So maybe you, Alex, you mentioned you were from maybe the more cybersecurity angle at first. So working now in ZK with Rarimo, how different is that? Is working in ZK different, or do you feel like it shares maybe some ethos with the cybersecurity world? So yeah, is there anything special with ZK or?
I would say it's totally different because. As it was mentioned that the technology is cycled, so probably, I don't know, 6 years ago I investigated how post-quantum cryptography worked, and right now, for example, a lot of applications use Starks. That's also, quantum resistance. So I believe, in the future we will find something new. That's totally different. So I don't know how to explain that and what we could expect.
The fact that it's a new field makes it a bit different in that you have to explore compared to cybersecurity, where you are more like using previously existing maybe techniques or tools.
In the past, we had a concept of some like manageable zone when you can control all processes. But right now, I believe we need to make some trustless applications when you cannot be sure that some particular trusted party or some particular trusted environment is definitely trusted. Yeah. So we can build some primitives and we can build some applications when, why we have built Rarimo? Because right now, user can generate all proofs locally without like delegating any processes to some dedicated party. That's only the single way how the future can be organized. Because I don't believe that, for example, I don't know, why WorldCoin built some closed source technology. It will not, it will be like that in the future because that's how it's. Some time ago, all encryption standards also were closed, and it wasn't a successful model. Right now, we have a lot of proved standards, and for the whole industry reuses standards. I believe,
That's a bit related to the fact that the space is very much open source.
Yeah, exactly. Open source, and that also should be proven mathematically. Okay. So you cannot just close something and say, that's secure, don't touch that, and nobody will receive some sensitive information from this model.
Okay, yeah, that's interesting. How about you, Tracy, maybe from this software engineer side, in the companies you've worked before, do you feel like there's a difference in the ZK space with what you're working on with Pluto, the people you're interacting with, or I don't know, is it pretty much any software engineering industry, made of the same people talking about the same stuff?
It's a good question.
You can say the same. I mean,
it's definitely different. I'm trying to reflect on how.
Maybe the values, maybe almost like a philosophical aspect of things. Maybe it's a bit too strong of a word.
I think one concept in software engineering is the idea of like iterative development, right? Moving very quickly, iterating toward a more perfect state over time, and experimenting your way into it. I think there's a little less margin for error in cryptographic systems. So if you're going to deploy a verifier and it's managing financial assets, it's very hard to iterate your way into getting a bridge right.
You can't miss. It's not hit and miss. Don't hit.
It's not okay to like
miss.
break the bridge halfway through. Like actually, in software engineering, there's like the classic analogy of like, software is different because we don't have to build bridges like to prevent like collapse during an earthquake, right? We can like iterate and improve it over time.
Mistakes.
In crypto, you literally have to build the bridge like it's going to collapse during an earthquake. So I think that's a big difference. And I actually think one good thing we can learn from classic software engineering is like how to bring that iterative design concept into the development of these types of systems. So I've seen some teams, like I think Scroll is doing this, like a multi-prover, right? Where you have many different mechanisms that are being used to prove correctness of their rollup. What else?
Diversify your risk type of thing.
Yeah, it helps diversify the risk. That's one that comes to mind.
Okay, yeah, that's a good one. And yeah, how about you, Alan? Did you feel like coming from the AI world, and are AI companies different, working differently than ZK companies? What do you think?
Yeah, definitely. I think there are huge differences. I actually come from the mixed background of both AI and pharmaceutical industry, so
Yeah,
they
true,
are
you
already
mentioned.
pretty different
They are.
from each other. And then both of them are kind of different from what I was currently working on. So basically the ZK field. So maybe I can just focus on one of the aspects there is the pace, the evolving pace of the whole industry. Because in pharmaceutical industry, like you have to do tons of different experiments to attest the corresponding compounds, the potency, the toxicology, all these kind of things. So it's going to be taking a lot of time, right? So you just feed these kind of compounds to monkeys, to pigs, and then until they have some kind of reaction, it's going to be taking you like 2 to 3 months or even half a year to actually get a result. So that is why this field is kind of evolving at a very slow pace.
Yeah.
I mean, in high contrast is the AI field where it's just evolving at a super fast pace. And the reason I was thinking about it is that the tools in AI is more or less becoming more and more complicated, and then also more complete in terms of their usability, their developability, their developer friendliness, all these kind of things. So people can just use these tools to, within several lines of code, create very complicated models. This cannot be imagined like 12 years ago when people just come up with AlexNet. At the time, EDS Suskever just write us some CUDA code. It's something similar to today where we are just coding some circuits.
Yeah.
Right? They do have the very large of the analogy. Right? So people just spending so much time doing this kind of handwriting things. And then after that, TensorFlow, PyTorch comes out, Theano, all these kind of tools comes out. And then it opens the door. The deep learning opens the door for all the people. All the people can just code some lines of a model, then it can just work. Right, so that is why like many people are emerging in this field, and then making the field AI field is paving at a very fast pace.
Yeah.
And I do think that the similar thing will actually happen for ZK field, because there's ZKVM, there's coprocessor that we are actually building as well. There's ZKVM heroes here. So basically, we are building something that is kind of similar to the AI world, the PyTorch and the TensorFlow. We are building this kind of tool to enable people, to enable developers to enter this field with a very low barrier.
Yeah.
We don't have to look over
very
this.
low, much lower.
Yeah, much lower. People don't have to understand about ZK.
Yes.
So they just write some raster code, write some MIPS code, then everything works well.
Yeah.
Right? Comes with the ZK proof. Right. So I think that's basically the difference. So basically, to conclude, I think between AI and the pharmaceutical industry, ZK is something that is in between in terms of pace.
The development cycle.
The pace. And then I think it will catch up with the AI field as long as we all together make
Do
this
our
kind of happen. Do our job. Yeah, exactly.
Interesting. Yeah, you want to add something, Ming?
Yeah, because I was inspired by what you just said about software engineering and the tolerance, and, about that. And I was reflecting on this between software and math, because we all say like ZK is based on math, and even one of my I think it's QED. Their practice model is trust in math or something, right?
Yeah.
So we trust in math, but you can't actually trust in math because you're not doing math. It's software. Software is not
Trust
equal
the
to
math
math.
that someone else
Yeah,
did.
and software has bugs. I mean, yeah, like mathematical proof, they might also have some problem that probably will discover 100 years from that was published, but the software bugs are prevalent, right?
And even the quantum aspect that you brought up, I mean, technically, trust the math until it gets quantum.
Yeah. So how we, like as an entrepreneur and software engineer, you have to live in now, right? And now the reality is the software has bugs, and also there's a performance, right? It's more powerful. It actually, you have to give up or trade off on like performance or like price, right? It could be costly. So, one reflection on this is that you have to always remember it's not just a machine. You can't have a machine doing everything, but there's always human. So, for example, in terms of like trustlessness, right? Trustness or trustlessness, If humans don't like complain, just let it pass, right? So all the transactions, doesn't matter if it's bugs or problems.
Sounds very much like optimistic proof.
If it's finalized, it's finalized, right? So this is coming from the world of optimistic. So I like to use like a broader term like verified by computing. So verified computing, verified by who? By humans, right? I know it's a machine, but behind it's humans. So remember that I think you always have to deal with software problems. There's always a trade-off. So yeah, I take I don't take ZK as like strictly like the gospel or something. I still see it as a software system. Any system, it's always flawed. Yeah, anyway, it's nothing.
No, but that's an interesting.
I'm not reaching anything, but I'm just reflect on what you just said. Yes.
Great. That's a great point. And maybe to wrap before we wrap things up, is there a thing maybe you would like to tell the people here to get them maybe excited about the ZK field? So typically something that you're working on right now that gets you excited, and that would get other people excited. So maybe maybe Oleks, you can start. What is exciting that you're working on at Rarimo at the moment?
Yeah, that's very long story.
Yeah, maybe. Yeah, I was expecting you would say that. So maybe in 1 minute.
Okay, yeah. First of all, we started as an aggregator of different protocols that are building their digital identity solutions. So we have built like as a network of oracles that just can aggregate this information and broadcast our different networks. Then we found out that government has issued millions of passports. And definitely we asked if that's signed. And we figured out that what is a passport? It's some kind of data signed by the government, and this part of data includes some sensitive information about like particular person. And you can create a proof that the signature is correct. You can create a proof that particular data is included into the passport. And it was a first component, the smallest component of your digital identity. Then we have built two solutions for voting. And for example, in Russian case, you can prove that you're Russian, and your passport is eligible, so it's signed by the government, but without revealing who are you. And it created a really powerful tool how you can be anonymous but eligible. And that's the way how people can vote, because they cannot vote publicly. That's pretty dangerous. Yeah. But with zero knowledge, that's totally changed. Right now, we're gonna build kind of ZK social graph, because passport is very weak part of personality. So we are talking right now, and you don't require my passport. You require some kind of another social attributes I have. And the final goal is to create this network of attestations, of some commitments, different kind of passport data, Twitter handles data, etc., etc., etc. And when you have this zero knowledge graph around particular person, you can create queries top on that and prove only selective, you can selective disclosure some data, keeping your sensitive information private. That's very difficult, and that's the reason why we are doing this stuff.
Yeah, no, that's this kind of very tangible use case. Using ZK in a concrete real life use is really fascinating.
Yeah, exactly, because it should be totally, as I mentioned before, it should be totally trustless, public, but at the same time, hidden infrastructure.
ZK enables that,
exactly.
Makes it possible. So that's very interesting. How about you, Tracy? What's the one thing very exciting you want to mention that you're cooking at Pluto?
I think anonymous identity is actually super interesting. So I'll second that first. I can see a future where it's harder to operate online without a lot of PII about a person, so that you can know that they're a human, and having some anonymous credential you can carry around and use on any website just seems inevitable. So I'm excited about that one. Yeah. But the thing I've been thinking the most about lately is the formation of new markets. So I think cryptography can let you form markets that haven't existed before. So you can create markets around Web 2 data. That one has been talked about a little bit, but I'm also excited about markets around data specifically, so data marketplaces. So one idea I've shared is, imagine you can coordinate 200,000 consumers to share their Chase financial history. And then you can privately sell some piece of that data to a hedge fund manager. And they can buy that data to help inform their buying decisions for equities. That's like one tiny example of a data market.
Yeah.
But if you, on the demand side, have all internet data, and on the supply side, have anyone on the internet who wants to buy data, you can build arbitrary information markets. So
yeah, that's funny because here it's more like ZK actually opening the door for new markets in this case that never existed before.
right, and if it's peer-to-peer technology and you don't need a custodian, you can build these global, like you can build markets globally and different small segments where anybody wants to exchange some amount of data. So that's pretty cool.
Yeah, very interesting. And so it's funny how you dripped this AI part at the beginning. So maybe I don't know why, but you already came back to that. But at Brevis, I mean, maybe forgetting about the AI, is there anything that you're working on at Brevis that gets you excited and you want to share with the people?
Yeah, of course. One of the things is still related to AI, actually. We actually did some work, research work on ZKML, actually.
Okay.
You know, like for the past years, people have been fascinating about this ZKML work, but it's still kind of far from being practical. Another thing would be like for most of the years, there are many great frameworks like Easy Code, like Modulus Lab. They have done a great job. But the thing is, like, they are most of the time they are just optimizing over the ZKML, the performance of the ZKML, from the standing point of ZK instead of ML. But the ZKML is just like two words, right? It's the two field. It's the ZK plus ML. So what we have come up with, or the philosophy behind our optimization procedure, is that we need to do the co-design and co-optimize from both the model side, which is from the ML world, and also as well as the protocol side, which is from the ZK world. So basically, we have discovered a new type of model that is very ZK friendly, and we have designed special kind of protocol that actually leverages and take advantages of these kind of ZK friendly features, and then make the whole ZKML framework to be 100 times faster to 1,000 times faster.
Okay.
So what does it indicate? Because basically it can be more and more closer to being practical. So basically you get an inference and you can attest and assure that model is actually doing the thing that you want. So there are basically many different potential applications for ZKML being practical, but I would just use a very personal one. Because originally I was a paid user for ChatGPT. And then every time, after a long time after it's a big update, it seems to me that its intelligence level is going down to some extent. And makes me, there's always some kind of rumor saying that, okay, maybe they are using the different model. It's kind of a cheaper model, so that there's not that so much computation that is involved. So I'm a paid user, right? I want to actually assure that, okay.
The best model.
Exactly, I'm paying for the correct model instead of some cheap model, right? So that's my personal thing. If the ZKML becomes really practical, then I can actually do that. So every time I just test the model, the inference is actually coming from the correct model.
Yeah, I see. Yeah, very interesting. It's still related to ML.
Yeah.
And closing words from you, Ming. What's getting you excited these days at ZKM? Turn it on.
Yeah, so for ZKM, we're kind of finishing up the the old challenge of using ZK to do scalability for Ethereum, right? So it's probably a down SOPs problem, not by us or any specific project, but collectively the whole industry. So I think the next more exciting direction, I think, for ZKVM is interoperability. We developed another solution called Entangle Rollup, which is a cross-chain rollup that we call a bridges bridge. So you would have native assets, native security across different blockchains, and that's pretty exciting for us. And we already spin off a project called Gold Network, and check that out.
Okay, awesome. Well, thank you very much, guys, for all these insights. It was a great chat. And yeah, we can, I think we have 20 minutes left. So yeah, maybe help yourself with whatever is left. And thank you very much for the chat. And thank you for attending. Thanks, guys.